Good morning, students. Welcome to video lecture on electromagnetic waves and transmission lines. Subject code U18EC403. Topic Coulomb's law. Before going to the topic, let us discuss the type of charges: point charge, line charge, surface charge, and volume charge. Point charge: the total charge is situated at a single point. Line charge: uniformly distributed over a line with line charge density rho L. Surface charge: uniformly distributed over a surface with surface charge density rho S. Volume charge: uniformly distributed over a volume with volume charge density rho V. The units are Coulomb per meter, Coulomb per meter square, and Coulomb per meter cube. The differential charge dq in the case of line charge is rho L dl. Here dq is equal to rho S ds, dq is equal to rho V dV, and the total charge q is equal to line integral of rho L dl. Here for surface charge, double integral of rho S ds, and in case of volume integral, in case of volume charge, it is the triple integral of rho V dV. And in the case of point charge, if it is a positive charge, the field lines are away. The field lines or the flux lines are away from the charge. If it is negative charge, then the field lines are towards. Now here you can assume if a positive charge and a negative charge are kept side by side, then you can assume the direction of field lines are flux lines. Coulomb's law. It is an experimental law formulated in 1785 by Charles Augustin de Coulomb. It deals with the force between point charges. Coulomb's law states that the force F between 2 point charges Q1 and Q2 is, along the line joining them, directly proportional to the product Q1 Q2 of the charges, inversely proportional to the square of the distance r between them. The magnitude of the force F is equal to some constant K into Q1 Q2 by r square. Here it is the magnitude of the force. In general, the value of K can be considered as 1 by 4 pi epsilon, and if the medium is free space, then epsilon is equal to epsilon naught. Coulomb's line vector notation, this can be represented as F is equal to 1 by 4 pi epsilon naught. Let us assume some Q1 charge, Q2 charge. It is the position of origin, Q1 with position R1, Q2 with R2. Now it is the distance, R is the distance between the Q1 and Q2. Then this can be formulated as Q1 Q2 by R square AR cap. AR cap is the unit vector along the line joining them, and this can also be formulated as 1 by 4 pi epsilon naught Q1 Q2 by R cube AR bar, where AR cap is the unit vector and AR bar is the vector. Regarding the constants, epsilon naught is equal to 8.854 into 10 power minus 12 farad per meter, and if it is free space, then epsilon is equal to epsilon naught, and the constant 1 by 4 pi epsilon naught is equal to 9 into 10 power 9 meter per farad. Just make a note. If it is unit vector, then you have to consider the r square value. If it is a normal vector, then you have to consider r cube. It is very important. Where AR cap is AR bar by R, where once again R is the modulus of the R. Force on point charges. Uh, Let us assume some position of origin Q1 charge with position vector R1, Q2 charge with position vector R2. What we require is we are supposed to calculate the force on Q1 due to Q2. The force on Q1 due to Q2 is in this direction. So uh, we can represent the force on Q1 due to Q2 in this notation, and the position vector in this direction is at what point we require the force is Q1. So you can consider the position vector AR bar as R1 minus R2. Now here the force equation F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square AR to 1 cap. Here it is AR to 1 bar, AR to 1 cap is R1 minus R2 divided by the modulus of R1 minus R2, where the modulus value of R1 minus R2 is simply R. So we can rearrange this equation as force on Q1, that is 1 by 4 pi epsilon naught Q1 Q2 R1 minus R2 cube R1 minus R2. Refer to the equation. The next is force on Q2 due to Q1. Once again, consider the same point charges Q1 with position vector R1, Q2 with position vector R2. Here at this moment, I am going to calculate the force on Q2. That is the force on Q2 due to Q1. Force on 2 due to 1. To calculate the force on Q2 due to Q1, uh, we require AR12 bar is equal to force on Q2 means you can straight away consider the position vector R2 minus R1 and AR12 cap is equal to R2 minus R1 divided by the modulus of R2 minus R1. Once again, the R2 minus R1 is simply the distance between point charges. Uh, Now let us write the equation for force. Force on Q2 due to Q1 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square AR cap, or you can write 1 by 4 pi epsilon naught Q1 Q2 by R cube AR bar. Here force on Q2 due to Q1, so AR12 cap 12 bar. Now in terms of position vectors, the force on 2 due to 1 can be written as 1 by 4 pi epsilon naught Q1 Q2 by, here R is the modulus value of R1 minus R2, sorry, R2 minus R1, and multiplied by the vector R2 minus R1. In this fashion, you can determine the force on Q1 and the force on Q2. Refer to the formulas just now we discussed. Force on Q1, force on Q2. Force due to n number of point charges. Here, uh, let us consider Q1 with position vector R1, Q2 with R2, like that. Qn with Rn, n number of point charges are there. At a point, we are supposed to calculate the force on charge Q with position vector R. That is, the force on Q due to n number of point charges can be calculated as F is equal to Q by 4 pi epsilon naught. K is from 1 to n number of point charges. At what point we require the force is R, so you can consider R minus RK and R minus RK modulus cube. Electric field intensity. The electric field intensity is represented by capital E and its units are volt per meter. In simple words, it is defined as force per unit charge at that point, at the given point. You just make a note of a given point. Suppose you want to require the electric field at a point P, then you are supposed to calculate the force at the point P, and it must be divided by the charge at the point P. It is very important. Electric field at a point P is equal to force at P divided by charge at P. The force on Q2, that is 1 by 4 pi epsilon naught Q1 Q2 by R2 minus R1 modulus cube R2 minus R1. What we require is you are supposed to calculate the field at Q2. To determine the field at Q2, what you require is you are supposed to calculate the force at Q2 divided by the charge at that point. Uh, that is force at Q2 divided by Q2. The force at Q2 divided by Q2 will give this equation. And one important point is while calculating either force or field, always charge must be in Coulomb, distance must be in meters. Then only we can say that the force is in newtons, the electric field is in volt per meter or Newton per Coulomb. Uh, Once again, the electric field at Q1. To calculate electric field at Q1, you are supposed to calculate the force at Q1 divided by the charge at the same point. You will get the equation based on the force equation. Electric field intensity due to n number of point charges. The same concept you can apply here. Whatever the concept we applied in the case of force due to n number of point charges. That is the electric field at point Q due to n number of point charges. Here assume Q1 with position vector R1, Q2 with R2, like that Qn with Rn. We are supposed to calculate uh, the electric field intensity at a point R with charge Q. That is what we require is we are supposed to determine the force at Q due to n number of point charges divided by the charge at the position vector R, and it is given by the equation and refer to its simplified version. Electric flux density. Electric flux density D is defined as the electric flux per unit area, and its units are coulombs per meter square. Now here D is equal to electric flux per unit area means the electric flux is equal to surface integral of d dot ds, where d is the vector, it is a vector quantity, though the electric field and force are also vector quantities. uh, ds is the differential normal surface, and also d is equal to epsilon e, and from that you will get the value of d is equal to q by 4 pi r square ar cap, where e is equal to q by 4 pi r square ar cap, as d is equal to epsilon e. Epsilon term gets cancelled. Refer to the sample problem. Charge q1, q2 with their coordinates. One more charge q3 at another point, let it be P1, P2 and P3, or you can construct this as R1, R2 or R3. What we require is we are supposed to calculate the force on charge Q3, that is equal to force on 3 due to Q1 plus force on 3 due to Q2. You're supposed to calculate the individual forces and to add to get the final value of force on Q3. You'll get the value of force on Q3. Refer to the answer. And the electric field at Q3, it is equal to you are supposed to calculate the force on Q3 divided by Q3. You can follow this procedure, or you can follow the general equation given. The force on Q3 is equal to 1 by 4 pi epsilon uh, summation Qk r minus Rk. K is from 1 to n. Modulus of r minus Rk cube. You can follow this general equation, or you can calculate from the force also. You will get the value of electric field intensity from this equation. Refer to the sample problem. Thank you. We will meet with the next lecture.